Hello everyone, I'm Linda. Today I'm going to make a short presentation about solar farm grid energy storage. What is solar farm? Solar farm, also known as the solar parks or solar power station, or with a large-scale solar panel installation. It can generate up to thousands of megawatts of solar powers. It generates energy in the same way as a typical rooftop solar PV system. A solar panel captures energy from the sun and sends this in the form of direct current DC to a solar inverter. Here it is turned into the alternating current AC electricity, which is a usable form of electricity for homes and businesses. Here I will talk about energy storage technology. The storage technology most frequently coupled with solar power plant and electrochemical storage with battery or with PV plants and thermal storage fluids with CSP plants. Storage helps solar contribute to electricity supply even when there is no sunlight, and it can also help smooth out variation in how solar energy flow on the grid. These variations are attributable to changes in the amount of sunlight that shines onto photovoltaic PV panel or concentrating solar thermal power or CSP systems. For electrochemical storage, when electricity is fed into a battery, it causes a chemical reaction and energy is stored. When the battery is discharged, that chemical reaction is reversed, which creates voltage between two electrical contacts, causing the current to flow out of the battery. During the discharge cycle, the positive electrode is the cathode and negative electrode is the anode. Electron flow from the anode to cathode generating the electricity. Whereas during the charging cycle, the reverse reaction happens and the positive electrode is in the anode and the negative electrode is the cathode, as shown in the figure of the slides. Electrochemical energy storage. The battery converts the chemical energy content in its active material into electric energy by electrochemical oxidation, reduction, reverse reaction. The most common chemistry for battery cell is lithium or include the other common option, lead acid sodium and nickel based battery. In the lithium battery, lithium ion move between the cathode and anode internally. Electrons move in the opposite direction in the external circuit. This migration is the reason the battery powers the device, because it creates the electrical current. While the battery is discharged, the anode releases lithium ion to the cathode, generating the flow of electrons that help to power the relevant device. For the thermal energy storage, the thermal system uses heating and cooling method to store and release energy. The most material used in this thermal energy storage system are molten salt, water, or phase change material. The thermal energy storage is a family of technology in which a fleet. As mentioned before, the material used is molten salt and or even water and other material. Molten salt are often used with concentrating solar power CSP plant to store thermal energy for electricity generating. It starts from a large mirror focus the sun ray on the central collection tower. The molten salt is heated in the tower tank and then pumped into the storage tank. And the heat salt is then pumped through the steam generator. The steam is used to power electric turbine and electricity is generated. And after that, cool salt is returned to the second tank to be sent back to the cycle. In this slide, we'll talk about the advantages of energy storage technology. For electrochemical storage, it has high energy density, it can be rechargeability, has long life cycle life with a high efficiency. While the thermal energy storage, it can balance the energy demands and supply on a daily, weekly, and seasonal basis. It also can reduce carbon dioxide emission and cost, while increase the overall efficiency of the energy system as well. And here is some references that support this video. And finally, thank you for your attention, and I hope you enjoyed this video.